Hi everyone, welcome to the Canberra AWS user group for July 2020. You will have noticed that your normal stunningly attractive host isn't in front of the camera just yet. That's because Brian's going to be helping out with the main presentation tonight, so you're stuck with me as for the intro at least. So as usual, at our agenda tonight, we'll talk through a bit about what's new in AWS, some of the training updates that you can expect, and it's been a pretty hot month in the world of Whitepapers, so there's a lot to talk about there. And we've also got, as I said earlier, our main presentation from none other than Brian Farnhill on some AWS DevOps Tooling 101. So, what's been new in AWS in July? So since our last meetup, it's been a pretty busy month. We've had 204 new features or releases since our last meeting. So a very busy month. And because we are, as usual, people that love charts, you can see that there is some data to back up that being a busy month. And so still got a couple of days to go to get a few more there as well. So what's new? One of the biggest things for us here in Canberra this month around what's new is some updated IRAP compliance information's been released. So personally, love to be able to talk about the AWS Artifact service, but there's a blog post linked to there. We've got 33 new services added to scope, and you'll notice a couple of interesting bits and pieces in there. So in the list of services there, you'll see that we've added some new components to stuff that was already certified. So for example, now the virtual private cloud assessment includes Transit Gateway. And I'd also call out there AWS Outposts. When you go into the Artifact service and have a look, you'll actually see there's a separate compliance report for Outposts as well. But this brings significantly more capability to our assessed services, and highly recommend you go and have a look at that if IRAP compliance is a thing that is important to you. Other than that, the AWS Well-Architected Framework has released a big update this month as well. So both the tool as well as all of the white papers have been updated. So anyone in this call who has to think about the architecture of applications on AWS, well worth having a look at all of those, all of that content to get some of our best practices and lessons learned from working with thousands of customers. And Migration Evaluator has been released. Now, for those that have been around for a little while, this used to be called TSO Logic. This helps you can build your business case for migration to cloud. So it allows you to analyze the workloads you have running in your on-premises environment today and helps you build out cost estimates for what that would look like to run in AWS, as well as some of the things like Microsoft SQL Server licensing and the impacts of that as well. Really, really worthwhile way of getting some data behind any business cases for a cloud migration that you're putting together. The AWS team have had a busy month. So as an Amazonian, I love a good price reduction, and the price for Microsoft SQL Server RDS has just got a bit cheaper today. So in Sydney, it's now in high availability mode. I think it's 27% cheaper than it was, which is a wonderful thing. RDS Proxy is also generally available now. Now, RDS Proxy is a way to help your applications keep consistent and scaling connections through to your RDS instances, now generally available. And the AWS Outposts team have announced that RDS is now supported for MySQL and Postgres on AWS Outposts. And that means you can use the same set of CLI and API calls that you're used to managing RDS and manage them in the Outposts as well. And a couple of interesting application announcements this month. So the first is App to Container, which is a tool that lets you containerize and migrate applications to AWS. So this works for both .NET and Java applications, and it'll actually do the analysis and it'll actually convert them into containerized workloads automatically as a part of that. Really powerful way to accelerate migration into a containerized environment. And the other one is the Porting Assistant for .NET, which is actually an analytical tool to help you migrate your existing .NET framework apps into .NET Core and help you understand where some of the pointy parts of that transformation might be. In terms of what else is new in our 204 announcements this month, there's just a couple of bits and pieces here. So in EC2 launch version 2 for Windows has arrived, which gives a consistent way of bootstrapping your Windows instances in EC2, as well as providing a consistent way to launch EC2. And automatic backups for EFS. Now, personally, I don't particularly like managing backups, so I love it when someone else does it for me. So EFS having automatic backups is a fabulous thing. And Control Tower has started to add some improvements to the visibility of OUs and accounts, and it gives you a bit more visibility into that when you're managing your multi-account environment via AWS Control Tower. And lastly, CDK pipelines, and I've put this in just as a bit of a segue into our next talk as well for Brian. The CDK is it's a construct library for putting pipelines as code via CDK. Really, really interesting capability. So if that's in your wheelhouse, I highly recommend you have a look at that. I do note that it's only in preview at the moment. In terms of training this month, so still we live in a very COVID world, so there's not a lot of in-person training going on, but have a look on AWS training for what's coming up. But also added in the online tech talks. Now, the online tech talks are a bunch of online webinars that run primarily out of the US, so the time zones can be a bit interesting for some of them, but there's some really, really fabulous deep dive content there. So highly recommend you go and have a look. So for example, the RDS proxy that we just talked about in our What's New, they've got a level 300 deep dive on how to on best practices for using that coming up in the coming days. So highly recommend you go and have a look at that library, and if the time zones work for you, then definitely get into some great content there. White papers. So it was a huge month. We've got 35 new white papers released this month or updated. And primarily the big ones obviously is the well-architected framework that I talked about. So not only the main AWS well-architected white paper, but also all of the white papers for each of the pillars of well-architected have been updated as well. And following on from our autonomous driving talk last month, thought it worthwhile pointing out the autonomous driving data lake white paper, as well as a bunch of others there that are very, very interesting in different dimensions. So certainly the security checklist down the bottom is a follow-on to the security pillar of well-architected and can help you go through some of the controls related to that. But there's a lot of white papers this month. Highly recommend you go to the link down the bottom there and have a look at the library that came out this month. So following on from that, as we usually ask, what would you like to hear? So please do get in contact with us. We really want to have sessions that you want to hear. So if you've got any ideas about things that you'd like us to talk about, or even if you've got an idea for a different format or something that you'd like to try and talk to us about, reach out and get in contact. Either Brian or myself can help you with that one. And also, please, in Meetup, submit your feedback. We do actually read it and we do take action on it. We really do. So please let us know what you think about what you're seeing, and we'll do our best to make sure this is exactly what you need each month. And of course, friends don't let friends miss the AWS user group. So please tell your friends and bring everyone along, and we'll make this an even better little community to be a part of. And with that, I'd like to hand over to Brian.
Excellent. Alrighty. Hi, everyone. It's different to not be doing the intro this month, so thank you, JJ, for stepping up there. So this month, I'm going to take you through a bit of a DevOps Tools 101. So seeing as I'm the main presenter, I'll give myself a bit more of an intro. So for anyone who's not met me, I am Brian Farnhill, so I'm a Developer Specialist Solutions Architect at AWS. So what that means is I work with a bunch of customers. JJ's ruining my audio. All right. We good? All right. So I work with a bunch of customers across public sector in Australia and New Zealand, helping them with anything that smells like DevOps, basically. So how they build code, how they build applications, how they do releases, how we optimize and automate and plenty of things in that sort of space. So what I want to take you through tonight and is a bit of a view of what exactly is DevOps to start with, and then I want to focus on just the tooling piece of it and what tools do we have in the AWS ecosystem that can help you implement modern DevOps practices. I want to give you a bit of a view of where the different services sit in the overall process. So, we've got a lot of different services in that place, so being able to give you a bit of a view of the end-to-end and what that looks like is something that I spend a bit of time discussing with customers as well. And I also want to point you towards some resources where you can go to learn how Amazon builds solutions and how we solve complex problems. So, to kick things off, what is DevOps? Now, it's one of these topics that you can go and ask a bunch of different people, and you'll probably get a bunch of different answers based on individual experiences around what people think DevOps is. Some people will tell you it's a philosophy, it's a big cultural change. Some people will tell you it's all about just aligning developers and IT and give them better communication and collaboration. Some people will say it's just how we make software deployment better. It's just breaking down barriers between dev and IT. Some people will tell you it's just tools and software. Some people will say it's agile. The reality is it's all of the above. The way I like to describe it is that it's just not this. This developer throws code over to operations and hopes for the best. So it's bits of all of them. And when I break DevOps down, when I'm talking to my customers, we're typically talking in three main focus areas. We talk to the people, the processes, and the tools. So tonight I'm going to focus pretty much exclusively just on the tooling side of things, but I want to really just call out that there's a lot more to it than just getting the tooling right. Getting your team structures right and getting your people right, getting your skills right in those people, getting your processes right around how you do releases, how you do validation, how you do testing, how you respond to incidents. There's a lot of stuff in the people and process area where we could just talk about that for whole sessions and not even touch the tools topic. But tonight I wanted to take you through the tools and show you some of what that looks like. So to give you the bird's eye view of tooling in AWS around DevOps, this is kind of what it looks like. And there's a lot of different boxes and circles here. So we have a range of CI/CD tools. We have infrastructure as code tools. We have an IDE, monitoring and tracing tools. We have code analysis tools, tools for web apps and mobile apps. We have languages in Amazon Corretto. We have CLI and scripting tools. We have a repository service now. And then we have all of our IDEs and toolkit integrations, as well as our SDKs across languages. Now, what this equates to is just a very, very broad set of learnings and skills that we've brought into these services that we sell onto customers based on both our own experiences in developing software. Amazon.com's been around since the mid-90s and AWS since 2006. We've been building software that scales for a very long time. And as a result of that, we've learned a lot of things in the process. We've also been listening to customers for a very long time. And we feed all of that back into our services. And so when you really get under the hood with a lot of these things, all of that heritage and that customer request and feedback and those iterative loops, you'll see those in these services. And I'm going to take you through a bit of a high-level run of some of them today. So I want to talk first, before we get into the guts of it, about changes to modern delivery of software, and then I'll map that into some of these services. So we've built these tools based on Amazon software delivery practices. So you can go through and do a lot of reading, and there's plenty of reInvent talks and other places you can go to hear about how Amazon and AWS build software. You'll quite frequently hear us talking about how we decompose teams, or more colloquially speaking, the two-pizza team concept. So if you've not heard of that, that's essentially a way of sizing teams where you say if it takes any more than 2 pizzas to feed that team, then the team is too big and should be separated into 2 separate teams. We talk a lot about automation, and you see a lot of this in the tooling and how it works in terms of trying to take human and manual elements out of processes and automating more of the things. We talk about standardizing tooling, and being able to bring it all into the AWS ecosystem has a lot of benefits there. We talk around, so we call it belts and suspenders. This is the governance part of the talk. So how do I apply compliance and configuration management? How do I template things? And the CDK is something that's been playing in that space a lot as well. And that also then ties into the infrastructure as code concept. So these are the driving principles and practices behind how we build software, and essentially then how we build the tools that help us build software. So what this looks like in terms of how customers sort of move from the monolithic development practices into more modern DevOps practices, it goes on a bit of a journey like this. And this is also pretty closely mapped to how Amazon.com did this. So in the early 2000s, it was about an 18-month to 2-year-long project where Amazon.com got broken down from that monolith into a more microservices-based approach. If you look at Amazon.com today, there's somewhere in the hundreds of microservices that contribute to rendering just that product detail page. So where does it get the product images from? Where does it get the pricing details from? Where does it get the descriptions, the reviews? All of these individual pieces are microservices that then talk to other microservices. So for us, the start on this was around what do we do with the developers and moving them from one gigantic bucket into individual teams. So this is back to that whole people component of the DevOps cycle. From there, we got to a point where teams could start building individual services, but we got to the point of everything was still going through one pipeline. So what do we do about that? The answer was that everybody gets a pipeline. You get a pipeline, you get a pipeline, you get a pipeline. But this is where a lot of these principles of infrastructure as code really come into play. I don't want to have to be standing up build servers and release servers and test servers for every individual project, particularly when you're moving into a microservices approach where everything gets its own pipeline. You need things that you can use templates for to scale quickly, deploy quickly, and start adding value quickly. And so with that mindset there, I want to take you through the AWS tools that we use and that customers use in AWS to achieve that. So what we've got here is just a basic sort of DevOps flow from development through to source code, building and testing, deployment, and monitoring. It's sort of fairly generic breakdown of the end-to-end DevOps flow. You could probably draw this out in a circle because it's a continuous thing, but for the sake of my PowerPoint skills, this is what we've got. Now, from the development end, there's a few different things we've got. We've got Cloud9, we've got the tools and SDKs, we've got the CDK, and we'll talk through all of these services as we go. We've got CodeCommit, CodeGuru, and CodeArtifact, all helping around source code management and creation of source code. We have CodeBuild for being able to create and compile code, create your actual executables that you will release, and also being able to run your unit tests. Deployment, now this will vary dramatically based on what exactly you're deploying, but there's a few services that might come into play here, things like CodeDeploy, CloudFormation, or Elastic Beanstalk. And then at the monitoring end, we've got a few services that come into play here as well. Amazon CloudWatch, AWS X-Ray, Amazon CodeGuru. Now, the guts of this all gets automated by CodePipeline as well. So these are the main services that I want to try to talk you through tonight and just introduce what each one does and give you a bit of an idea behind why you might want to use each one. So I'm going to start from the left of that slide there, and we're going to begin with the IDE, the development environment. So for that, we've got AWS Cloud9. So if you've not heard of Cloud9, it's a managed IDE that runs in the cloud. All you need is a web browser and you're good to go. Essentially what it does is it creates an EC2 instance that it drives all of the things that you're doing from a code perspective. So you still get a terminal where you can run commands to install programs and execute things, build code, run tests, all of those sorts of things. But it's all done in a web browser. So this has got a bunch of different benefits to it, and a lot of it come out when you start asking the question, well, why would we even come up with a new IDE? There's a lot of different IDEs out there developers are already using. Why would we add another one? And there were 4 main points to call out here that really sort of show where Cloud9's value comes into it. The first one is that developers have been building for the cloud, but running on local machines. All right, so getting it running in the cloud helps you simulate things a little bit easier than you can get from running on a local machine. Things like how your IAM credentials work, things like being in the same VPCs, subject to the same security groups, the same auditing mechanisms, all of that sort of thing. It's cumbersome to set up new developer environments. Now, as somebody who's been a developer for the good part of my career, I cannot tell you the number of times I've gone through and said, I'm going to set my development environment up again. I'm going to install my IDEs and all my libraries again. And, it's 6 months later, I'll decide, no, I need to change it because I'm on a different project now. You can actually go through and really easily create them for different projects. I could have an IDE set up with all of the dependencies for project A and then a different one for project B with its dependencies. And then because they're all on just EC2 instances, you only pay for what you use. So I'm only paying for the time that the EC2 instances are running when I'm building for project A or for project B. Developers need an easier way to collaborate. This is one of the things that is really great about Cloud9. It is very, very easy to invite another developer in because it's all based in a web browser to be able to get them to see what you're working on, to see your environment, and not just look at it like a screen share, but interact with it. So you can click into different places, see where each person's got the cursor going, type in the code, type in the terminal, type into a chat window there. So you've got a really great mechanism for facilitating things like pair programming or remote code reviews. And lastly, IDEs haven't really caught up to the needs of serverless applications. Cloud9's got a couple of really great integrations to the serverless application model, so SAM, where you can really easily spin up an API gateway or Lambda environments to be able to execute those and debug them directly from Cloud9. So if you're working in that serverless world, Cloud9 can actually speed up your development flow. Now, the next one I'm going to talk about is CodePipeline, because it's going to help automate the rest of the processes that follow through to the release and monitoring stage. So CodePipeline is essentially pipelines as a service. It's completely managed, it's highly available, and all you do is just define your pipelines. You don't have to set up servers. You don't need to configure and patch everything. There's also a couple of really great things I like to call out about CodePipeline. First of all, it's completely pay as you go. If it's active in a month, so there's been something that's happened on it, then you pay for it. If it's been completely inactive, you don't. Also, every pipeline comes with a 30-day free period to encourage experimentation. You can create a pipeline and have a play around with it, and as long as you delete it within 30 days, it won't cost you anything. So it's a really great way to get in and have a play with it and see what you can do. CodePipeline integrates with a bunch of different AWS services, and you'll sort of see those as we go through. But it's also worth highlighting that you can connect to other services run by third parties, things like GitHub or Jenkins. There's a big list of other things that you can integrate with, as well as creating your own custom integrations too. As I mentioned, it scales automatically. So think back to that diagram where everybody gets a pipeline. This is really important because as your teams grow and the number of projects grow, you don't need to then say, I need more servers or I need more hardware, more software, more overhead to be able to do this. You could take the same template for a pipeline and just deploy another instance of it, and you're good to go. Lastly, it integrates with all the usual AWS configuration management and compliance tooling, so things like AWS Config and CloudTrail. So to give a couple of examples here, because I like to try to talk to how some of these services can get used. One of the common discussions I've been having with my customers are around how do we run our pipelines across multiple environments like dev, test, prod. So what I've got here is actually some screenshots of one of the pipelines that I use to drive my own website. And the one on the right, there's a single pipeline that is designed to take everything through to production. So you can see source code, the build, the release into the dev environment. Then I've got a safety check block where I'm doing a manual approval to decide, do I want that code to go to production or not? And then after that, into prod. Now, that's one approach. And one of the great things I like about CodePipeline is it doesn't really lock you in. So when I decided that, you know what, that process doesn't really work for me anymore, I wanted to move to using a more branching-based approach. I ended up with what's on the left, two separate pipelines, one that releases to dev and one that releases to production. This actually enables a bunch of different things for me, such as doing code reviews when I'm doing pull requests from my dev branch to my master branch. But it also means that like the production stuff can get released very, very quickly afterwards because it's not having to go back through dev. So this is one of those scenarios where we'll say there's trade-offs between each option, and your mileage may vary. So pick the one that works for you, but we're not really locking you in. It's very flexible, and you can move between these models as you want to and play around with it under that 30-day free period for each pipeline. Now let's talk about where we put source code. CodeCommit is the AWS Git repository service. So again, it's fully managed, it's highly available, it's durable, it's encrypted at rest. It integrates with IAM for security. So this is great because it means I can do things like single sign-on with AWS SSO to be able to have a single identity across all of AWS, including how I do my source code. Now, we integrate with a lot of native code tooling around Git. And so what we've actually got there is credential helpers that'll let you translate your AWS SSO credentials back into that. So that way you've got the ability to go through and just use your standard tooling like you've always used, but go and put it into CodeCommit. Question there, can you compose Can you compose pipelines so you can archive and achieve your aggregate pipeline? I'm not quite sure I understand that. Are we talking about like pipelines that call pipelines? Is that the question there? JJ can deal with that. I'm going to keep talking. So things to like about CodeCommit, that IAM security and access is one of them. It integrates with all of that same standard AWS compliance tracking as well. So you've got everything logged to CloudTrail, which is good. So that way I don't need separate tools to track what's happening in my environment because I've got a separate Git server running somewhere else. It's all part of the same AWS ecosystem. Also, it's free for the first 5 active users each month. So as long as there's less than 5 active users in your account in each month and you're not using any more than 50 gig of storage, you're not going to be paying for it. So it's a really great place to be able to put your source code. Again, back to some of what I was talking about there with the pipelines as well between the branches. This is sort of the approach that I see a lot of customers trying to move to now. We see customers discussing what is a branching strategy. And, in the worst case, I've seen customers have these massive documents, like 20, 30-page documents that say, here's how we're going to do branching in our source code repositories. I like to keep it lean. It's what's in dev and what's in master. Now, this so mainline or trunk-based development approach essentially means that you shouldn't be using feature branches, or they should be very short-lived. You want to get stuff back into the dev branch very quickly, so that way you avoid merge conflicts. Now, that doesn't necessarily work for things like open source stuff on GitHub, where you might have a very long-lived feature branch by the nature of it's just me chipping away at something over weeks or months before I submit a pull request. But in day-to-day development, this model tends to work a bit better. You can use pull requests to then do quality checks before things go off into production. So you can do this as a manual thing, or you can start to automate it with tools like CodeGuru, particularly as we expand language support there. So we'll talk through CodeGuru in a little bit as well. Catching up with that conversation. Reuse on pipelines. Yeah, so reuse on pipelines. I'll let JJ answer that, but if he doesn't do a good enough job, we'll come back to it at the end. All right, so CodeArtifact is the next service I want to talk about. And this is one of our new services. This actually only came out fairly recently. What CodeArtifact is it's a fully managed repository service. So it's got support at the moment for NPM, Maven, and for Python, where you can connect it to an upstream repository, like a public NPM repository, or the public PyPy or Maven repositories, to be able to bring packages in from those public places, as well as publish your own private packages. So if you've got code that you're trying to reuse in multiple different applications in your environment, CodeArtifact becomes a really good place to put it. The other benefits of CodeArtifact is it gives me the ability to approve packages for use and to get visibility into the package usage. So let's take a scenario here where maybe my security people say, yeah, you know what, there's a third-party package here that we don't want anybody using. What we can do is we can import that to CodeArtifact and we can ban it. So that way it is not approved for use. And anyone who tries to pull from our CodeArtifact repository to be able to go and request that package will get a rejection. So this becomes really then critical when you look at how you do your builds to make sure your builds are pulling requests from CodeArtifact instead of from public repositories. But it gives you a really great security control around dependencies. If you talk to security people around third-party dependencies, there's usually a lot of opinions there around risks that are involved in that. So being able to have the mechanism to audit usage and potentially whitelist or blacklist usage of dependencies is a really interesting use case there. And so we created a service so that customers can go and do that. Again, it integrates with IAM for all your authorization and access, and also it has a private link endpoint. So what this means is that if I've got developers who are working inside of a VPC, they can access this service directly from the private link endpoint without requiring internet connectivity. So if I'm trying to do highly secure development and to share dependencies in a highly secure way, this private link endpoint lets me create a very locked down environment where nobody's got internet access, and the only way that they can get to these dependencies is through my CodeArtifact service, where I'm approving packages for use. All right, CodeBuild is the next piece I want to talk about. So this is where we take the source code that we've committed into CodeCommit, we take dependencies that I'm pulling from CodeArtifact, and we go and we compile something. So this is our managed build environment service. So you can go through and create whatever the artifacts are that you're trying to release. So in the case of a web app, it might be compiled web app code. It might be a Java app. It might be a mobile app that you're building. It could be an infrastructure app where I'm building stuff with the CDK. The good thing about CodeBuild is it scales up and down automatically based on your build needs. So if my team of 100 developers all go and commit a bunch of stuff in and I need to trigger 100 builds at the same time, CodeBuild will just scale for that. And then at the end of it, it scales back down. You only pay for the time that your builds are actually running. So this is really, really great from a scalability perspective. CodeBuild's also got a lot of pre-configured environments that you can then customize if you need to. But the pre-configured environments make it very easy to bring in specific versions of dependencies and to do so in a very quick way. Again, as with the rest of the code suite, it's all connected to IAM to control who can interact with the builds. But because it's also happening in a compute environment, you can give an IAM role to your CodeBuild server so that it has permissions to go and do other things. For example, I might want to, once I'm finished a build, go and invalidate a CloudFront distribution or put something into S3 for argument's sake. Another really great feature that went generally available in CodeBuild earlier this year was the ability to visualize test results. So tests are usually something you'll execute at this point as well. And at the end of that, you might want to go through and visualize those to see how many ran, how long did they run for, what was the pass-fail rate. So here's a couple of screenshots of what that test result visualization looks like. As you can see, when I took them, the pass rate was 100%. So clearly I had not broken any of my code at that particular point in time. But it gives you an idea of where the failures were, and you can drill down further than this in to see the individual tests that passed and failed. So if you've ever run unit tests in CodeBuild before and you've tried to figure out where things have passed and failed, you've probably found yourself scrolling through the log output trying to find the test components. This makes it much, much easier. So you can publish any of them as long as they're in, I believe it is, NUnit XML format, directly into the CodeBuild service and have a nice web-based way to interact with your test results. Okay, so moving a little bit further along the pipeline, we get to CodeDeploy. So CodeDeploy is, again, a fully managed deployment service that can automate software deployments to a variety of sources. So we can deploy to things like EC2 instances. We can deploy to Fargate for containers. We can deploy to Lambda for your completely serverless applications. You can also use it to deploy to stuff on-prem. Right, so it doesn't even need to be in AWS for you to be able to leverage CodeDeploy to help automate those deployment processes. I want to give you a bit of an overview of how CodeDeploy works in terms of just some of the concepts, because it'll give you a bit of an idea about what the flow is and how it works as a service. So we start in CodeDeploy by creating an application. So it's essentially a collection of software that I would like to deploy to somewhere. So a group of web server instances or to Lambda. You create revisions of that software, so version 1, version 2, version 3, as many as you need to. So this is your compiled source code, essentially. You have your instances that you're targeting, so EC2 instances, could be containers, could be stuff on-prem, could be Lambda functions. But essentially, this is where you deploy stuff to. So once we've got our application and revisions and our deployment groups, we start talking about how we can combine the two of those by doing deployments. Now, in this case, we create what's called an AppSec file. This tells CodeDeploy how to go and do a deployment. Right? So if you ever think about the last time that you might have written a deployment guide back in the day where DevOps was not a thing and we threw the code over to the infrastructure guys, you probably wrote some sort of document that says, click here, run this command, copy these files, do those sorts of things. The AppSec file here is basically a configuration file that tells you what needs to be done, where the files need to be copied, and what scripts need to be executed. The deployment is essentially a way of saying take version 2, deploy it to this deployment group. It'll read the AppSec file and go through and do that deployment. The last piece is the deployment config. So this defines the behavior for how you're going to proceed. So there's some interesting scenarios in here, things like failure handling. What happens if something goes wrong during this deployment? How do we automate a rollback? Do I automate a rollback, or do I just notify someone? So you can sort of see all the moving parts here to start to think about how you can automate the deployment of applications without involving humans in a way that is completely repeatable and scalable. Again, in CodeDeploy, you're only paying for the deployments that you're running and the time that you're using the service. So it makes it really, really easy to get them out there, automatically roll things back if they fail based on like CloudWatch alarms, and be able to have that really consistent deployment experience between environments. Now, getting into the deployment phase for other things like infrastructure projects, and we come into AWS CloudFormation. So CloudFormation is our main service for deploying infrastructure into AWS. You create text-based templates in either JSON or YAML, and you essentially hand the template to AWS and say, I would like you to deploy these things. And the CloudFormation engine goes through, figures out what needs to be deployed and how you want to do it. Now, in the case of a DevOps pipeline, there's a few different deployment approaches that you can sort of work with here to control how you deploy your CloudFormation. So you can use what we call a change set to stage a deployment and to preview the changes before you execute them. So this is a really good habit to get into because it lets me evaluate, am I about to delete something important as I execute this change? So if somebody's accidentally taken something out of the template. You can use CodePipeline to then maybe put an approval step in between. So if it's a really critical application in a critical environment, I might want to do a manual approval, or maybe I can automate some steps to validate that nothing's being deleted in that change set. So you can start to see how we can build some of this approval and compliance in an automated way into the pipeline process. You can also then use CodePipeline as well as CloudFormation's stack set functionality to deploy a CloudFormation template across multiple AWS accounts and multiple regions as necessary. So it makes it very, very easy to start scaling out to multiple environments and deployments. Now, there are some really good benefits to using CloudFormation that I like to call out because one of the common pieces of feedback that I get from people who aren't familiar with doing infrastructure like this is it's just easier to click a few buttons, or I know the CLI command for that. But CloudFormation's got some perks to it that really warrant getting into templating your infrastructure like this. Things like automatic dependency management in my template. Right, so for example, if I go through and do something like create an S3 bucket and then create a CloudFront distribution that's going to surface the content in that bucket, I don't need to give any thought to the order it needs to provision those in. I can put them in whatever order I want in the template. The CloudFormation engine will automatically resolve those dependencies for me. So this makes it easier as an author to create templates. We have drift detection for a number of resources. Not everything yet. This is coming in for more and more resources over time. But what drift detection does is it allows me to say, tell me about the current state of something that was deployed from a template, and tell me what was in the template, and do all the properties match? So this is a really great way to say, did somebody manually change a resource without updating the template? So it makes it very, very easy for me to try to track those manual changes and remediate configuration drift. CloudFormation gives me resource policies that can protect provisioned resources and control who can change them. We get stack sets, which I was just talking about there for that cross-account and cross-region deployments. And also for supported resources, we have the ability to import things that you manually created into a CloudFormation template. So say, for example, I go through and create a VPC with an EC2 instance. I can choose some of those resources and import them into CloudFormation. It will generate the template for me based on the current state of what was deployed. So if you, for example, were just manually building something out to say, yeah, will this work? And I'm just doing a quick experiment, and you decide, yeah, it does. You can use this resource import to create a template and start managing it in that infrastructure as code kind of way. Now, as good as CloudFormation is, anyone who's written CloudFormation at any point in their career will tell you that it does come with some challenges, particularly as you get to very large templates, as well as things like trying to validate them before you deploy it. I think we've all been at a point where we've deployed a CloudFormation template. You wait 10 or 20 minutes to find out that there was an error, and then you wait 10 or 20 minutes for it to undo those things. So to head off some of that and to give a much better developer experience around creating infrastructure as code, we built the AWS Cloud Development Kit, or the CDK. So I know we've talked about this in multiple different presentations. We had a whole session on it earlier this year. But essentially the CDK gives you a whole lot of benefits when creating these CloudFormation templates. It gives you a lot more accurate IntelliSense around properties and things that you're building as you write the code in your IDE of choice. It's got a lot of best practices built into it, so things like automatically creating a unique IAM role for every Lambda function, right, without you having to go through and remember to add the additional resources and do the permissioning right. It's got a lot of these best practices baked into the constructs. You have the ability to unit test a template that is generated using language native tooling. So because the CDK lets me create a CloudFormation template in one of a bunch of different languages, I can go through and just write unit tests on that in much the same way as you would any other application code. And it also makes it really easy to create reusable constructs that will shortcut the work being done by app development teams. So to sort of visualize a couple of the concepts I was talking about there, also the language support on the bottom of that slide. So TypeScript, JavaScript, Java, .NET, and Python are the languages that are currently supported for the CDK. But we essentially come up with this concept of constructs, where everything in the CDK is a construct. And a construct can have child constructs. So, for example, I've got one construct here that has an SQSQ and a Lambda function in it. Each of those on its own is a construct. I've got another one here with S3 and multiple Dynamo tables. The net result of the CDK application, though, is it will generate a CloudFormation template. So I don't need to write YAML or write JSON. It will just build this for me, and then I deploy it to the CloudFormation service. Now, this creates some really interesting design paradigms. So let's say that I want to create and reuse some stuff in the CDK. I've got the ability to say, let's create a template. And for argument's sake, let's say I'm doing a static website that's got CloudFront and WAF configured in a particular way. My infrastructure team has come up with this as a template and said, this is how we do this. So we're going to make sure that all of our developers go through and use this template. Once they've created that template once, they can publish it to a central repository, e.g. CodeArtifact. It's a really great place to publish CDK constructs. And then as teams are building applications and they say, hey, wouldn't it be great if we had a static website with CloudFront and WAF? Instead of having to code the entire thing in the CDK, they can drag that construct in that was created by the core infrastructure team, apply the properties that need to be put in, and the CloudFormation template that gets generated will still have all of the actual resources there. But as a developer in that app dev team, I have spent significantly less time trying to build that. So this whole sharing of reusable constructs is something that we're starting to see a lot more of. So from the announcements that JJ was going through earlier, man, it's been a long day, that JJ was going through earlier, he talked about the CDK pipelines. This is just a collection of another reusable template that's provisioning things like CodePipeline, S3 buckets for artifacts, all of the appropriate bits there, without you having to code all the individual resources. So that's just another example of a higher level CDK construct that can save you time as a developer. Elastic Beanstalk, I throw this one in here because it sort of crosses the line a little from sort of I'm deploying code to it and I'm also monitoring it, and it's a way to help some of the DevOps processes that might work for your particular type of application. Essentially, Beanstalk helps automate a bunch of other AWS services. So if I don't know a lot about auto-scaling and how to provision it and EC2 and VPCs and all of that sort of stuff, I can just say to Beanstalk, here's a zip file with my code. And that could come from a pipeline or it could come from me manually uploading it. Just make it go. That's where Beanstalk comes in. So it does that infrastructure provisioning. It gives me some really easy to control properties around things like auto-scaling and security configuration, but it's also got a lot of automatic updating built into it for things like operating system and runtime updates. And it also can help you deploy your application in a bunch of different ways. It can do things like blue-green deployments, rolling deployments, and automatically roll back as well. So you've got a lot of that baked into Elastic Beanstalk. The great thing about Beanstalk is it also doesn't cost you anything. You only pay for the resources that it provisions for you. So if I say, give me 2 web servers in a VPC with a little bit of EBS storage, that's what I'm paying for. I don't have to pay for any of the additional things that Beanstalk does for me around how it helps automate those updates and deployment of my code. So if you're working in one of these languages, so .NET Core, PHP, Java, Ruby, Go, Node.js, or Python, these kind of apps all port really, really easily into Elastic Beanstalk because we've got native runtimes. If you've got something that doesn't fall into one of those, and you can put it into a Docker container, you can also use Elastic Beanstalk to do some of that. There's probably a more interesting discussion to be had there around Elastic Beanstalk versus something like Fargate, and your mileage may vary. But there's a lot of different options to be able to bring apps quickly and easily into Elastic Beanstalk. Now, another one of our new services, this one got announced at reInvent last year and has only recently, I think, maybe in the last month or so, gone generally available. How did we miss that from the updates? So CodeGuru, for anyone who's not heard of it, is essentially a machine learning-based analysis of code service. There are two components to it, and they will play in at different parts of the pipeline. The eagle-eyed among you, when you saw that first slide where I laid out all the services end-to-end, might have noticed that CodeGuru was in there twice, and it's for this reason. CodeGuru comes with a code reviewer component designed to help you review your code as you do pull requests. And it comes with a live profiler component, which is designed to help analyze performance of your code as it's running. Now, today, it only has support for Java-based runtimes, so running code in Java and any JVM-based runtime in terms of the profiler component, but there is additional language support coming soon. But essentially, it's designed to help you find your most expensive lines of code really, really easily. And I think the thing that really speaks to how well this works is if you go to our website and have a look at CodeGuru and scroll to the bottom where we have the customer references, you'll see there's a bunch of big customers in there, but at the bottom beneath that, there's a bunch of customers that are us. There's AWS service teams, in particular DynamoDB and CloudWatch, who, as we were testing CodeGuru to figure out, does this work and will our customers find it useful, who started running CodeGuru and finding all sorts of ways to really optimize the services that we run and the code that we write in ways that hadn't necessarily been immediately apparent to those teams, but something that's using machine learning has been able to really easily pick up on and say, hey, here's how you can improve your code. CodeGuru has been trained on a bunch of code repositories that are internal to Amazon and AWS, as well as I think it's about 10,000 or so public repositories from GitHub to be able to really, really understand lots of different types of code and different ways of writing code. So it can make some very intelligent recommendations to you. So as you're doing a code review, you'll see that it comes up with recommendations like this. So here's an example of a Lambda function where what's been done is a DynamoDB client has been provisioned inside of the handler. So this, for anyone who's played around with Lambda, is not a pattern you should follow because it makes your Lambdas take more time to run on every subsequent call. Whereas if you provision it outside of the function, it'll get provisioned once, and as long as that container lives, it won't need to do it again. So CodeGuru has found that and made a recommendation here. So it tells you what's gone wrong. It gives you a link to best practices for working with Lambda functions. But you can also see it says there, provide feedback on this recommendation by replying to this comment or by reacting to the comment using one of the emojis. So GitHub and CodeCommit both have the ability in pull requests to add emoji reactions to individual comments in a pull request. We use that to determine, is this a useful bit of feedback? If you, for your project, say, you know what, no, that's not relevant, you could give that a thumbs down, and that'll help that machine learning model not make that same recommendation to you in that repository again. Whereas if you like it, it's like, okay, cool, that one was relevant, we'll use that to train the model for further use. So what this does is it's not designed to replace a human code reviewer. What it is designed to do is to help make that human code reviewer's time dramatically more efficient so that I can get a bunch of recommendations automatically fed in with relevant links to help train people on what could be done differently. And I can spend more time focusing on maybe the application specific parts that are, business logic specific and not generic best practices. So what you end up with is much better code reviews before you even get your code out the door. The second piece, and I didn't update the title on this slide because it still says reviewer, is the profiler. So what the profiler does is it runs alongside of your applications and it's able to watch the individual threads and functions that are happening and tell you how expensive they are overall using a flame graph here. So what I'm able to do is then start drilling down through and having a look at the total CPU time and things like that. But it also does this interesting thing where it tries to put an estimated dollar figure on what that function's actually costing you to run. We know a bit about the infrastructure that you're running on, the instance types that you're running on, and how this is looking. So you can see an estimated active CPU cost there per year of what that function's costing you. Putting dollar figures onto things is a really interesting way to make developers pay attention to what's being done because back in the days that was a finance problem, that was not a developer problem. So this makes it really, really easy to go and find ways to really optimize what you're doing based on real live conditions and knowing what's in your source code repository. So that's CodeGuru. Other tools in the monitoring space to be aware of, CloudWatch. Man, I've had a shock with the slides because that still says CloudFormation. CloudWatch is our managed centralized monitoring service. So if there's anything that feeds metrics out of one of our native services, CloudWatch is where it ends up for the most part. Managers will be asking. So CloudWatch will feed all the metrics into places so that you can track them from a bunch of different sources, such as native services, as well as capturing your own custom metrics. So you can run an agent inside of operating systems to catch metrics that we can't directly see. So things like memory consumption is a common one. And you can then go through and visualize all of this into dashboards with charts and visualizations and all these sorts of things that operations people really love. There's a few other really cool things about CloudWatch, though. It has the ability to look for trends and anomalies using machine learning analysis of your data. So, for example, one of the common patterns I see people do is put an alarm on an instance to say, tell me when the CPU goes above 80 or 90% or some line in the sand. Where, that's moderately useful to tell me that the server's busy, but if it's, the middle of the day and, we've had an email go out that's told everyone to come to this website, I would probably expect that. So what CloudWatch has the ability to do here is to look at patterns for what is normal. So if 80 or 90% during the business day is normal for your application, it's not going to trigger an alarm there. But if running at 80 or 90% overnight is, that machine learning model can help your alarm trigger and tell you that there's something you probably want to pay attention to. And it sort of helps eliminate a lot of those false positives. Man, my icons. X-Ray. is the last one I wanted to talk to you about here. So X-Ray is a service that we provide to help you trace requests through a microservices-based architecture, particularly useful where those microservices are coming through parts of the AWS ecosystem where you can't necessarily run your own code or to collect the telemetry there about what's happening. Think things like SNS or SQS, things like DynamoDB, for example, where you don't get access to the server, but you still very much so need to know what's going on from a performance perspective. X-Ray makes it really easy to figure out where performance bottlenecks are happening inside of your applications. And it's designed for a ton of different application types. You can do it for web apps, you can do it for mobile apps, serverless applications, and more. There was also an announcement that we made, I think in the last week or so. We've got a .NET specific version of the X-Ray agent, which will run and not actually require you to make any changes to your code to be able to gather a lot of these analytics. So if you're a .NET developer, now is a really good time to get into X-Ray. Question there, CodeGuru, does it help with code style guide conformance too? No, it does not. So you would still use a traditional linter for that function. So to be able to apply those rules and to do it in the IDE is probably a more useful point, right? I don't want to know that my styling is wrong by the time I'm doing a pull request. I probably want to catch that before I even make the commit. So having a linter is a more relevant tool for that function. With X-Ray as well, I wanted to show you this little visualization here. So X-Ray, when you tell it about an application, starts to track dependencies of your application and map out a service map of which components are talking to which other components. We then start to see the average time taken on each of those components, and if there's errors going on or throttling or faults, we see different colors on those circles as well. This makes it really, really quick to find out what's going wrong in my application, drill down on it, and then I can dive deeper than this chart shows into the individual traces and start looking at things in a lot of detail. So we can go from Lambda functions to SNS to DynamoDB. There's a lot of different services that have support for X-Ray. So this visual call graph is where a lot of the value of X-Ray comes out in terms of making it very quick to troubleshoot. So I haven't been through everything on this slide, and I'm not going to, because we will be here for another hour or so if we start getting into things like Amplify and some of the SDKs and the specific elements of those and the IDEs and toolkits. But hopefully you've seen enough of the tools tonight to sort of get a bit of a feeling for where, if I'm looking at a sort of DevOps pipeline and what I want to do with my team and my business, I can sort of figure out where the relevant pieces are that I want to pull out and start making use of. I want to call attention as well to what you get for free each month out of our developer tooling. So the AWS has a free tier where you can sign up for an account, There's a bunch of stuff you get for free for the first 12 months, and there's a bunch of stuff you get for free as an ongoing thing. Everything on this slide is in that ongoing thing. You will always get these for free based off what was on our website currently today. So things in CodeBuild, you'll get 100 minutes of the general one small instance for free each month. CodeCommit, you'll get those 5 active users, your 50 gig of storage and 10,000 Git operations. CodePipeline, you get 1 active pipeline per month for free. X-Ray, you can record 100,000 traces. And you can then go and scan 1 million traces to be able to retrieve them back out and not pay for it. CodeArtifact, for that new service there, you can put up to 2 gig worth of packages into a CodeArtifact repository and not have to pay for it each month. And lastly, CloudWatch, you can get 10 custom metrics and 10 alarms, 1 million API requests, 5 gig of log ingestion and log storage, as well as 3 dashboards before you have to start paying for any of it. So the thing I really want to highlight here is there is a lot of stuff you can do in the DevOps world in AWS before you even have to pay a cent. So it's worth looking at some of these services and really assessing them in a hands-on way to see, is this service going to do what we want to do? And lastly, I said I wanted to mention the lessons learned about how does Amazon build software. And the quote here from Charlie Bell, who's one of our VPs in AWS, says, "There's no question the world will be a better place if everyone can innovate more quickly and efficiently, and if stuff just works better. For that reason, I'm excited that we'll be sharing what we've learned with you in the Amazon Builders Library." So this came out of reInvent last year. The Builders Library is a collection of very technically deep white papers published by people who are building code and building applications in AWS and Amazon. So there's a lot of really interesting stuff about how we solve complex development problems that we say, let's write this down and share it with everyone. Like I said, AWS has been around since 2006. We've learned a thing or two about building efficient software at scale, and we want to share that with you. So the Builders Library is how we do that, and it's a really great place to go. Can I elaborate more on the new X-Ray update, which is .NET related that was mentioned? We use .NET Core and Lambda. We use X-Ray. Yep. JJ will grab it. There's a link in the What's New feed that talks about it. It's in preview is the tooling. I'll be honest with you, I've read the announcement that said it was there. I haven't kicked the tires on it to be able to tell you too much more than that, but we'll grab the link and see if we can drop it from the What's New feed into the chat window there as JJ frantically searches for that.
It's all good. I know what it is.
He knows what it is. It's going to be fun. All right. So in summary, AWS services, as far as DevOps stuff is concerned, are building blocks. The old phrase here that every service is for someone, but no service is for everyone is probably the line to keep in mind here. Depending on what type of team you've got, what type of app you're building, the environments that you're deploying into, some of these services will be really useful to you and others less so. So use the ones that make sense for your processes and bring in ones when it makes sense to do so. Again, I mentioned at the start the DevOps tools are only part of the story. Be mindful of the people and process parts. And also remember that a lot of this stuff is two-way doors. We're not building services that are designed to lock you in here. You can try them out, and if they work for you, great. And we genuinely think they will. We build them based on how we build software and how customers tell us that they build software. But if you use a service and it's not for you, that's fine too. Go and look at what's going to solve the problems you've got and pick the right services there. We're not trying to create any kind of lock-in from our DevOps services here. Now, my next steps that I really want to call out to everyone who's paying attention to this video still at this point, if you haven't already got an AWS account, go through and create one. There's a lot of stuff in that free tier there that you can have a play around with and really get a feel for what you can do with the tools and services. Have a look at the challenges your organization's facing around DevOps and see if you can pick at least a couple of services we talked about tonight that could help you solve those problems. And lastly, I'll challenge every single person here to go and find at least one article on the Builders Library and have a read of it to get a feel for the kinds of things that we're talking about and sharing and the technical depth of the content in that Builders Library. So on that note, I'm going to wrap up here as I get JJ to change things over for me as he's Googling frantically. So thank you everyone for coming along tonight and listening. Hopefully you've learned a couple of things around what the AWS services are in the DevOps ecosystem and where they come into different points in that pipeline. If you've got any more questions, then please, by all means, just drop them in the chat there. We'll keep an eye on that for the next little while. Otherwise, find me on Twitter. I'm at Brian Farnhill, and I usually enjoy the attention of a few tweets, so by all means, reach out to us. Otherwise, that's it for this month. Thank you so much for coming along. We will be back again next month. I have no idea what the presenter is yet. I've got a couple in the pipeline, so we'll get one of them locked down as soon as we can and get the details out to you. And my final reminder, as always, please submit your feedback. Let us know what you think of the content, because it really helps us in picking those right sessions to make this a genuinely interesting user group for all of you. Thank you so much for watching, everyone. Have a good night.